Hello. Alright, this will be the third example for the second lesson about the quadratic form. Alright, trigonometric equation involving quadratic form. So by looking at these equations, so there are 2 secant square plus with tangent square, it will be equals to 2 secant theta, right? Equals to 2 secant theta. So by looking at this equation, so I need to think out how to make sure that this equation become a quadratic form, right? Become a quadratic form. So tangent square and secant square, there is a relationship, right? We can using identity. Do you still remember the three formula, right? The trigonometric identity. So the Pythagorean identity, theta sine square theta plus cos square theta equals to 1, right? This is the most famous one. Sine square cos square equals to 1. And another one will be tangent square theta plus 1 equals to secant square theta, right? Can you see that? There is a relationship between secant square and tangent square, which secant square theta is the same as tangent square theta plus 1. So another one would be the cosecant square, right? So never mind. So we just use this formula to solve this equation, right? So at first I want to ask you which variable should I replace, right? Which should I replace? So very simple. So I can convert this, all right? Convert this into tangent square plus 1, all right? So tangent square plus 1, tangent square plus 1, okay? Oh, sorry. So I think that the one that I should replace, because there is a secant theta here, right? By power 1. So here secant square. So I think the one that should change is tangent square theta, right? Tangent square theta. Because after I change tangent square theta, the equation, everything will become in the form of secant theta, alright, in terms of secant theta. So okay, I remain the secant square theta, but I replace the tangent square theta with tangent square theta, which is equals to secant square theta minus 1, right? Minus 1. So I replace this with secant square theta minus 1 and equals to 2 secant theta. Now you can see that the equation already everything in secant theta, alright, in terms of secant theta. So it's easy for me, right? Okay, easy for you. So it will be 2 secant square theta plus with secant theta, you will get 3 secant square theta, right? So this one 2 secant theta, you move to the other side, you will get minus 2 secant theta. Alright, 3 secant square theta, 2 secant theta, and minus 1, right? Minus 1 equals to 0. Now you can see there is another quadratic form, alright? It's another quadratic form. So you're going to let the y, right? Let the y to be secant theta, right? Secant theta, which means that 3, I write again, rewrite, 2 secant theta minus 1 equals to 0. So I replace the secant theta with y. So 3y square minus 2y minus 1 equals to 0. Alright, now this one becomes a very easier job. So we should just need to factorize the quadratic into 3y, y, 1, 1. 1 will be positive, 1 will be negative. So I will put here to be negative because negative 3 plus positive 1, negative 1, negative 1, right? So you see here, positive, negative 3y plus y, you will get negative 2, right? Negative 2. So then I got 3y plus 1 equals to 0 and y minus 1 equals to 0, right? So y minus 1 equals to 0. So now you got y equals to negative 1 over 3 or y equals to 1. Okay, so now it's a time for me to solve, but have to remember that what is actually y? Y is actually secant theta, right? Secant theta equals to negative 1 over 3 and secant theta equals to 1. Alright, equals to 1. So, and you have to remember the identity for secant theta also. Secant theta is 1 over cosine theta. Right, this one is a very basic. So you have to convert back. Okay, for example, secant theta equals to negative 1 over 3, negative 1 over 3, and this is actually 1 over cos theta, right? 1 over cos theta equals to negative 1 over 3. So which gives me cos theta equals to negative 3, right? Cos theta equals to negative 3. So this is a case number 1, right? Case number 1. The second case will be secant theta equals to 1, which is 1 over cosine theta equals to 1, and cos theta equals to 1, right? So this one I already discussed in the previous example, where cos theta only can take the value, the minimum of negative 1 and maximum of 1, right? So this has got no solution, right? No solution for this case. No solution, because what's the reason? Explain, give a reason to reject. So because cos theta, if you study before, right, the graph for cos theta is a maximum 1 and negative 1. So this got no solution, so I'm not going to consider this. So now I'm going to consider this. This one is special case, cos theta equals to 1. Either 1, negative 1 or 1. I don't need to use the quadrant form. So I use the graphical form. So which you have to understand that the basic graph for cos theta. Alright, it starts from 1 and end with 1. So 1, so this will be 0, this will be negative 1, right? So along the x-axis there is 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree, right? 360 degree. So what you should do is you're going to see the diagram here. So which satisfy cos theta equals to 1. So can you see that 0 degree will give 1, right? So, and also 360 degree, you will give the value of 1. Means cos 0 is 1, cos 360 also 1. So there are two solutions. Theta is 0 degree or 360 degree, right? 360 degree. So finally, here got no solution. And the union of these two, you will get, therefore, the solution will be 0 degree and 360 degree only. There is only two values of angles that in this range and satisfy this equation, right? So I hope you understand the use of identity. This case special because they use the identity to help you to convert this equation become a quadratic form. Alright, alright, that's all for this lesson. I will give you another example for the next video.